Okay, so this is Python lecture number 2. If you have not seen Python lecture number 1, go back and watch that. Don't watch any of these, either of these two lectures until you've followed the steps in module, I think it's module 8. We'll see in just a second. No, module 7, the programming languages module, okay? If you have come to this video, then I presume you have seen it linked to from a page that looks very much like this. Now, as I'm recording this video, there's no link here to this video because the video doesn't exist yet. So we're in sort of a chicken and egg paradox at the moment. But you will have seen a page that looks like this, but has a video, a link to this video I'm currently recording. This then is something else you will have seen. This is the program, this is the programming assignment that we're going to start this lecture off with as solving this using Python. So it says you're tasked with writing a Python script for solving the problem as stated below. Python script computes the expenses for a college student. The script should ask the user to enter from the keyboard 4 different expenses: tuition, okay, books, total for food, and total for entertainment. Okay, so tuition, books, food, and entertainment. All right, so remember those 4. And the program should sum all the expenses and display the total. Okay. Include a couple of comments at the top of your script. You must include at minimum your name, the date, course number, and a description of what the script does. And note, the user may enter data with decimal places, so a type conversion will be necessary. And it says this is a 2-step process. Use, it says draw.io, but we know that this is actually diagrams.net. Use diagrams.net to create a flowchart that models the program described above. Be sure to include a text box with your comments, names, etc. at the top of the flowchart. Okay, and then submit that as a PDF file. Of course, there's no place to submit here, so you won't be submitting anything. And then use idle to create your Python script and submit that as a .py file. Now, we do want to make sure we are able to submit something in the cases where we need to. So we need to make sure we can export that as a PDF file and that we know how to find the .py file when we're done. Okay? So the first thing we're going to do is we are going to design our algorithm, and we're going to represent that algorithm through a diagram that we created on diagrams.net. Okay. There we go. Sure. All right, and then we give it a second. Okay. So what we know about every program is it begins with start. It's going to end with end. Okay. There is a process that it goes through in between start and end. In our case, we're going to get, and I'm forgetting something important. Up here, we're supposed to put a text box, okay, that has some information in it, not the least of which, at the very least, it should have this information: college expenses, okay, your name, okay, the class, and the date. In my case, May 25th, 2020. Okay, and that doesn't fit, so we'll do that. All right, so that has some comment information to help us remember what all this is, what this flowchart represents as time progresses. Okay, so we're going to be doing input to begin with, and we're going to have 4 input statements. So your flowchart does not have to look exactly like mine. It just has to have the same general flow as mine does, and it needs to encompass all the components. So I'm going to run out of room, so I'm just going to go over here. Okay, and the 4 pieces of input we're going to input are input from the user's tuition, okay, input the cost of books, input the cost of food, and then input the cost of entertainment. Okay, I'm just going to abbreviate that. I'm going to go ahead and put in the arrows so that we can establish the flow. This is the flow part of the flow chart. All right, so then we need to make a calculation. Right? And our calculation, which I'll put right here, looks like this. The total expenses is equal to tuition plus books plus food plus entertainment. Okay, and I want to put that all on one line, so I'm going to resize that. Like I said, that's not critical, but it just adds to the readability. And then the last thing I want to do is I want to output, okay, the total. Okay, so I'm going to do that, and I'm going to do that, and there we go. Okay, that's our flow chart. All right, that's all. It's a pretty simple program. It's meant to be simple. The notion of it is very simple. It's just 4 inputs, a calculation, an output, and we're done. Okay, so excuse me. So how do we do that in code? Well, here we are. This is the idle development environment, and I'm going to go and create a new script. Okay, just like we did before, and I'm going to save this as to my desktop. I'm going to save this as let's do example 1, or let's do college expenses. And it'll save it as a .py file. And before we go too far ahead, remember that we're also going to have to turn this in as a PDF. So we're going to do File, Export as PDF. Sure, all that's fine. Save it to my device. Okay, and it's going to ask where to save it. And because we're putting everything else there, let's put it on the documents. Sorry, on the desktop rather. All right, and we'll call this, what did I call it, the other one? We'll call it collegeexpense.pdf, and then we'll save it. Okay, so if we close all that and we go here, you'll find that you've got collegeexpense.py and collegeexpense.pdf. So when we're done, if this were a normal assignment, if there were a place to turn anything in, these are the 2 files we have been instructed to turn in. Okay. Well, we actually need to write this program. Okay. And it's fairly simple. You're asked to put some comments up top. Program to compute college expenses. Okay. Yeah, this is CS 135, and I'm Dr. Ray. And the date, again, is May 25th, 2020. Okay. All right, so first 4 things, we're just, all I have to do now, okay, I'm going to open up this PDF. Okay. All I have to do now is follow my flow chart. So I need to get input, 4 inputs: tuition, books, food, and entertainment. Now, each of these I'm going to treat as a different input statement in Python. There was an instruction, though, that they did not have to give me whole numbers, and I know I want to treat these as numbers to begin with. And from our last lesson, we know that we need to cast them to numbers, and to cast the strings to numbers, or convert the strings to numbers. And since these are not necessarily whole numbers, we need to convert them to floats. Okay, so we need to be careful about that. And then we're going to do this calculation, and then we're going to print out the result of that calculation, and we'll be done. So this shouldn't be too complicated of a program. That's the beauty of Python. It's never supposed to be super complicated. It's supposed to be as simple as it possibly can be, depending on what the problem is. So we're going to cast this to a float. This is an input statement. Okay, and the input statement is going to ask the user, how much was tuition? And be sure to close all of those parentheses. Right? Books. Okay. Float. Input. Okay. How much were books? Okay. What's next? Food. Float. Input. How much was food? Close. And then lastly, entertainment, which I'll just abbreviate to int. Right? Float. Input. Okay. How much did you spend on entertainment? Close. Okay. And then once we have those values, we're going to set a new variable, total, equal to tuition plus books plus food plus entertainment. Okay, great. Excuse me again. Then we're going to do print, and we'll print that information out. The total expenses were. Okay, and we're going to have a $ here because we're going to print out, we want that $ to show up. All right, percent dot to F. Now what's that going to do for us? Percent total. Okay, what's that going to do for us? Well, obviously the dot to F is going to give us a dollar amount. In other words, a floating point that's rounded to 2 decimals. So let's save this. Let's run it. Okay, so how much was tuition? Tuition was $35.45. How much were books? They were $1.25. Okay, how much was food? Food was $76.34. And how much did you spend on entertainment? About $9,000. Okay, so altogether you spent $9,113.04. All right, any questions about that? It's meant to be fairly simple to solve problems like this. You break the problem down, you figure out what your solution is going to be by flow charting the problem. Okay, that helps you see the structure of the program you're going to write, and then you convert that structure into actual Python code. Now it does get more complicated because we haven't done any branching or any looping yet, but we will do that this lecture. Before we do that, however, I want to talk to you about one other thing. I want to talk to you about, and I'm going to open a new file here. I want to talk to you about random numbers. Okay, random numbers. Now you have a sense of what the word random is, and so you have then a sense of what a random number is. It's a number that is generated in such a way that it cannot be predicted ahead of time what that number was going to be. Okay? Now there's a lot more to it. There's a lot more to random numbers than we're going to cover today. These are one of my favorite topics to talk about, but in the interest of time, I'm going to kind of cut all that out of this lecture because what's important to you is how to use Python to get random numbers, or in our case, pseudo-random numbers, numbers that are random enough. Okay, why are random numbers important? They're important for when you're writing games, when you're doing simulations, when you're running experiments, for educational software. You find random numbers everywhere. Okay, and in order to use random numbers in Python, you have to import a library called random. Okay, and you import libraries. Now, what's a library in terms of programming? It's just a set of variables and functions that we can now use in our code. Those functions have been defined in a different file, okay? And they're not always available to us because they make our programs larger, okay, when they run. But if we need them, then we can import the library and then we have access to those functions as if they've always been there. Right? Somebody else already wrote them. Somebody else already took care of the details. We're just going to import the library, and then we are able to use functions and variables that have to do with random numbers. So if I import the random library, then I can do things like this. I can do random.random. Okay. And what does that do? So I'm going to save this again to the desktop. It's just a convenient place for me. I recommend you put your code in a separate folder somewhere or on a USB drive so you can get access to it later. Okay, but this is rand test. Okay, so what happens? Well, what happened was this created a random number. Okay, but we didn't do anything with that random number. So instead, let's save this as num. Okay. And then we'll print num. Let's run it again. Oh, okay. 0.9568395. All right, let's run it again. What's the next random number going to be? Something else. And something else. I cannot predict what the random number is going to be that is generated. Now, it's always a number less than 1. Okay? So we're going to have to do things to process this random number to get ourselves some useful values. But these are unpredictable outputs that are coming from the computer. Okay, at least they're mostly unpredictable. They're unpredictable enough. Okay, which is how we're going to define random numbers. All right. So in this case, what if I do this? I can do random.rand. Whoops. Int. Okay. That's a new function. Notice when I put the parentheses up, it tells me that I need two values, a comma b. In this case, I'm going to do 1 comma 6. Okay. Excuse me again. Goodness. So this is going to say, it's going to give me a random integer between 1 and 6. A random whole number between this number and this number. Okay. So if I run this, right, I get a 6 the first time I run it, and a 3 the second time, and a 2 the next time. So this is equal to doing what? Well, this is effectively paramount to having a 6-sided die and rolling that 6-sided die and seeing what number you get. You know on a 6-sided die the numbers are going to be between 1 and 6. They're random, and that's fine. But they are constrained between 1 and 6, and that's what we've done when we're using this statement. Okay? We can also do something like this. Okay? And this takes 3 parameters. It takes a start parameter. Okay? So 1 to 100. Okay? And then we have a step parameter. So this is the start parameter, the end parameter, and the step parameter. Okay, let's do 5. Okay. So what kind of numbers am I going to get when I run this? Well, let's run it a few times. Okay. Six, 26, 86, 61, 21. Okay, so this gets me values between 1 and 100, but only every 5 values. And this might be easier to see if I do 0 to 100. Uh-oh, I think I froze up. Whoops, I think I froze. Hang on, I'll be back in just a second. Okay, sorry about that. I'm back, and it seems to be behaving itself now. All right, so again, this is rand range. So the first number is the lowest possible number that can be returned. The second number is the highest possible number that can be returned, and the step number tells you how many numbers in each step. All right, so let's run this program. Okay, so I got a number 90. If I run it again, you should see that these are either whole numbers, and that's every 10, so 20, 30. There's 35. Okay, so the lowest possible number in this case is a 0, and 0 plus 5 is 5, so that's the next possible number, and 5 plus 5 is 10, so that's the next possible number, and then 15 and 20 and 25 and 30 and 35 and 40 and 45, all the way up to and including 100. Okay, and so that's how rand range works. Now you're going to be using this less often than something like rand int. Right? That's probably going to be your most popular and useful function that you use. Okay. All right. So let's do this. Let's try and generate some dice rolls. Well, that's what we have here, right? So let's try and generate the result of rolling 2 dice. So I'm just going to repeat myself. Okay, and all I did was copy and paste there, right? And then I had num1 rand equals randint 1 comma 6, num2 rand equals randint 1 comma 6. This gives me a random number between 1 and 6 and stores it as number 1. This gives me a random number between 1 and 6 and stores it as number 2. Then I'm going to total these together. Okay, num1 plus num2, dice 1 plus dice 2. Right, and then I'm going to print out the total. Okay, and the values should be between 2 and 12. 3, 8, 10. Okay, so the numbers will definitely be between 2 and 12, right? Okay, so that's the general idea of doing random numbers, and we'll come back to this. It'll be useful to us later on. So if you have any questions about that, be sure to get them answered sooner than later. Okay, so the next thing I want to look at is selection, or your book says branching. Okay, so how do we do selection? I'm going to type up a program and then we'll talk about it. You, as I always recommend, should type this program into your own environment so that you have a working copy of it that you can play around with it in real time as I'm going over it. Okay. So we have a welcome message, and then we have an input function call with a message. All right, and then, so effectively what we're doing is we are getting a password from the user. Now we need to make sure if their password is correct, okay? And so if it is correct, we're going to do something. If it's not correct, we're going to do something else. So this gives us our if-else structure, okay? What does that look like in a flow chart? Okay, so I'm going to give myself a new flow chart. Okay, new flow chart. So we're going to begin with an input. I'm going to do this sloppily. Obviously, there's a start thing here. Okay, the input is input the password. Then we need to make a decision. And what do decisions look like? Decisions look like diamonds. Okay. Is the password correct? Well, in our case, the correct password is secret. Okay. So what I just did was I said, all right, is password equal to secret. But notice, I didn't use the single equal to. I used the symbol equal to, the double equal to symbol. This is the comparison symbol. If I do this, then the compiler is going to think that I'm setting the password equal to the value secret. But that's not what I want to do. The password is and should be whatever the user gave me. Okay? So instead, I want to check to see if the value of password is the same thing as the string secret. Okay? Then there will be two branches. Okay? Let me delete this. There are going to be two branches. If it is true, okay, so this is the true side. If that statement turns out to be true, and I'm going to highlight this by changing that to the equal symbol. So if that statement turns out to be true, then I want to do something. I want to print out the string access granted. Okay. If that statement turns out to be false, then I want to do something else. Access denied. Okay. Now, in a real program, there would be something else that I would need to do. Okay, but let's just say for the sake of argument that that's all this program does. So we leave the if-else statement, and then that's the end of the program. End. Okay. All right, great. So let's code this up. If password equals secret, and then we put a colon here. Then everything that is indented over the same number of spaces, 1, 2, 3, 4. I think it's 4 spaces by default. But everything that's indented, so everything that's indented in underneath this, it's only going to be executed if password is secret. Okay, so print access granted. Okay. Else, and everything that's indented underneath the else is only going to be executed if the password is not equal to secret. Okay. Print access denied. All right. So let's run this. It'll ask us to save it first. I think I have the. You don't want to see me. I think I have this open over here. All right. So yes, North Alabama Security Systems. Enter your password. Secret. Hey, access is granted. Okay. Now notice that because the password I entered is equal to secret, only this was executed. The rest of this was not executed. Okay, so let's run it again. What if it is not secret? Well, access denied. Okay. Anything you type in where this statement is not true skips all the indented over parts and goes to this. Okay, so can we have multiple things controlled by the same condition? Sure. Okay, let's try that. Okay, if I type in the correct password, then I see both access granted and hello and welcome. Okay, if I type in the wrong password, then I see access denied and no hackers allowed. Okay. What if I don't have these two things indented over so that they line up with the indentation above? Oh, okay. So invalid syntax. All right. Okay. Because this can't be a standalone thing, right? You have to have the if statement followed exactly by the else statement with everything in between indented over. Okay, well that's good. So what if I do this? Oh, it compiled. What's going to happen? So secret. Oh, it says access granted, hello and welcome, and then it prints out no hackers allowed. What if I type in not secret? It prints out access denied and no hackers allowed. Because this is not tabbed over, okay, or spaced over, then you don't get this line being controlled by this branching structure, even though you meant for it to be. The compiler sees this as its own separate statement. Okay, so the spacing in Python is extremely important. Okay, let's try a different structure slightly. Okay, let's try. What if there are more than one passwords? Okay, if password is equal to top secret, okay, and these colons matter. Okay, if password is equal to top secret, then print superpower access granted. Okay. Welcome back, Batman. Okay. So now what this is going to do is it's going to first check to see if the password is the string secret. If it is, it's going to execute everything that's tabbed over one tab space and skip the rest of this and then continue on with the rest of the program. Okay. If this is false, if password does not equal secret, it's next going to check, this should be read, else if password is equal to top secret, because it could be either, the password could be either secret or top secret. If it's top secret, then it prints out everything that's tabbed over one tab space before the else. Okay? If it's not this and it's not this, then it'll execute these statements, the else block. Okay? And you can have multiple if. You have a single if, you can have a single else, but you can have as many elif blocks as you want, right? So if there are 3 passwords, okay, then you have another one. Elif password, okay, is equal to kryptonite. Okay. Print Superman is a wimp. Okay. All right, so let's run this. We'll save it first. All right, so let's type in top secret. Okay. Superpower access granted. Welcome back, Batman. These are the 2 things we expected to be run. And then the last thing was this line. Okay. Let's run it again. What about kryptonite? Okay. Let's run it again. How about secret? Okay. And let's run it again. How about not a password? Okay, access denied. No hackers allowed. Okay. All right. Hopefully that makes sense. Now, when we add multiple conditions, then we have to reimagine what we're doing here. Obviously, it looks a little bit different. Okay. So instead of being an either-or proposition, right, what we have is a series, okay, of decisions that get made. So we need a string of diamond shapes. So if password equals secret, we're going to print out access granted. Otherwise, okay, we have another diamond. If password equals top secret, okay, then we're going to print out access, or whatever we print out, super access, or whatever we said, super blah 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 blah. Okay. Otherwise, if it's false again, if that's false, then we have a third thing, and I'm just going to stick to 3 things, even though our final example had 4 things. Hopefully you can extend this. You'll see the right. Well, let's go ahead and do 4 things. Otherwise, if password is equal to kryptonite, right, then print out Superman is a wimp, blah, 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 blah. Okay? And then if all of these are false, then the last thing is the else case. Else, we're going to print out access denied. Okay? Now, in either case, in any of those cases, if whatever of those becomes true and only one of them will ever be executed at a time, we're then going to leave the, in this case, if, elif, else block. So I'm going to have all of these point to this thing. Okay. Okay. And then the very next thing is our final output statement. Right, and that is, I don't remember what I output. It was just some garbage output, something, right? And then after that, that's the end of the program. Okay, so a single true-false statement is represented by one of these diamonds. If we have multiple branching conditions, then we need to have a diamond for each of those conditions. And so if this is true, then we go this way. If this is false, we have another decision to make. If that's true, then we exit and go this way. If it's false, we have another decision to make. True, go this way. False, we're going to go immediately access denied, print that out, and then print out the last output, and then the program's over. Okay? Hopefully it's clear that even though there are multiple possible branches, because only one of these is ever going to be true at once, okay, there is only ever going to be one path that gets us from start to end. Okay, and that's necessary. That's a necessary condition for what we were talking about for what makes an algorithm. Okay? Right, again, if you have any questions about that, do let me know. Okay, so let's do something slightly different. This is our last example before I let you go to work on your labs. Let's write a program that flips a coin 15 times and tells us how many heads came up. Okay? And it needs to be actually a random number of flips. Okay? Well, not a random number of flips, but each flip needs to be actually random. Okay, that is to say, we can't tell ahead of time. We know we're going to flip them 15 times. We can't tell if the coin is going to come up heads up or tails up, because it's actually going to be truly random. All right, so we need to import random. We've already done that in order to get that answer. So let's not worry about the 15 times to begin with, but let's look at how to do this once to start with. So I'm going to say coin equals, right, random.randint, okay, 0, 1. Okay, this is going to give me a random integer between 0 and 1. So each time I run this program, coin is going to be either 0 or 1, and it's going to be random if it's 0 or 1. A 0, I'm going to say, is a heads, and a 1 represents a tails. So if coin is equal to 0, okay, and this is an if-else statement, then we're going to print heads. Okay. Now, ideally, I would have already sat down, figured out the structure of this, made a flow chart, but you don't know how to do. We're kind of putting the cart before the horse here. I'm showing you how to do this in Python, and then showing you later on. I'll show you how to draw the flow chart. But that's backwards of the way you will normally want to do it. Okay. Else. Print tails. Okay. All right, any questions about that? So this is just one flip. So let's run it. Heads. Tails that time. Heads. Tails. Heads. Tails. We're gonna tails again. Okay, I just wanted to show you that it wasn't flipping back and forth every time. So it's random. Okay, heads or tails, because it's a random between 0 and 1. And if coin is equal to 0, count that as a head. Otherwise, in this case, it can only be 1. We print out tails instead. Okay. Now, how do I make this happen 15 times? All right, well, I can do this. So I'm going to create a new variable called count. I'm going to set it equal to 0. Okay, so count always starts at 0. Here's a new structure called a while structure, or a while loop. And a while loop, just like an if statement, has a condition. And in this case, the condition is going to be count less than 15, right? And then a colon to represent the fact that all these statements are controlled by that while statement. Okay? And at the end, we want to do count equals count plus 1. So we want to add 1 to the value of count. Okay? All right, and then when we're done, we're going to print goodbye. Okay, are we done with the program yet? No, because this is going to repeat 15 times. Okay, that's right. Now, how does this work? It says while. So if this value is in fact less than 15, then we're going to execute all the statements that are controlled by this while loop. When we get to the end of those, we go back up to the top, we loop back up, and check the condition again. So the first time we run it, count is going to be set to 1. So 1 is still less than 15, so we run it again. It's going to be set to 2. 2 is still less than 15. We run it again. It's going to be set to 3. 3 is still less than 15. Eventually, 15 will come up. We'll do it 15 times. But 15 will not be less than 15. So if this is false, Then we skip the while loop and we begin executing the rest of these things. Now what we're missing is we need to keep track of the number of heads. Okay, sorry. Num h equals 0. So every time we roll, we flip a heads. Okay, every time we get a heads, we're going to do num h equals num h plus 1. Okay, and so as a result, 1 will be added to that variable each time heads comes up, and then we'll print out num h. Okay. All right. So before I run this, let me try and highlight better what this is doing by drawing you a flowchart. And again, nominally, when we're not just learning the syntax, what we're going to want to do is we're going to start with the syntax. We're going to want to start with the flowchart rather. So it has a start. Okay. It has an end. Right. And the first thing we worried ourselves with was getting a random number. Okay, so we're going to generate a random number between 0 and 1. Okay. Now, if that random number, if it's 0, then we're going to print out the word, sorry. We need a parallelogram. We're going to print out the word heads. Okay, and then we're going to add 1 to num heads. Okay. If it's not, so this is the true side, here's the false side. Otherwise, we're going to print out tails. Okay. And that's going to be it. So we're going to leave this if-else block at that point. And then we're going to print out the number of heads plus goodbye. I'm going to get lazy here and put both of those in the same output. Create them both the same output. And then we're going to be done. Okay, so that's end. Okay, and then that's start. All right, and that's what this looks like without the while loop. Okay, so if we don't have the while loop, so I'm going to comment out this line, okay, and all the information about count. Okay, that's what that program looks like. And when we run it, we're only going to see one head flip, and it's either going to be heads or tails. And if it's heads, then we're going to print out the value 1. If it's tails, then the value is going to be 0. Okay, so we got a heads. The value, we only saw one head, and so we saw goodbye. The time we got a tails, we saw no heads, and so the program's over, goodbye. Now the one thing that our flowchart is missing actually, and I probably want to be careful about this, the one thing our flowchart is missing is that we actually set the value of num h to 0 to begin with. Okay, now, so that's what it looks like currently. All right, now, what we want to do is we want to repeat basically this chunk right here. Okay? And we want to repeat that chunk, that whole chunk right there, 15 times. So we need a new structure. We need a new structure for helping us to do that. Right? So I'm going to break this, and I'm going to break this, and I'm going to add one more statement here that is a new variable called count. And this is going to help us keep count of the number of times we have repeated, and it gets initialized to 0 as well. Okay, and so I'm going to just move this out of the way. We're going to need these later. Move those out of the way. Going to move these. Okay, so we have a new condition. Is count less than 15? Okay, and we also do, so to begin with, obviously count is less than 15 because count is 0. So if count is less than 15, then we go over this way. Okay, we connect to this. We do this statement. Okay, we do this statement. And then when we're done, in fact, I think it might be easier to see if I move things around. So bear with me for just a second. Okay, so this is the true side. Okay. And I'm going to mark this as true. The count is less than 15. True. When we're done, we go back to that decision. We loop back around to this decision. And there we go. All right, so this seems strange, and it's because the arrows, I'm making this up as I go along, but the arrow is a little bit confusing. But the first thing we do is we say, give me num_h equals 0, give me count equals 0. Okay, so that drives us down to this decision. If count is less than 15, we go this way. Right? We have a decision to make, just like we did before. This hasn't changed. Right? Those decisions haven't changed. I have a decision to make. Give me a random number. If it's 0, print out heads, and then add 1 to num heads. If it's not 0, then print out tails, and then come back to here. Okay? Now from here, we leave the if-else statement, but we return to the condition, is count less than 15? Well, if we always return true, because count is always going to be less than 15, then we're going to have what's called an infinite loop. So we're missing something. Every time we do this loop, every time we do this if-else statement, we want to add a new thing. Okay? So the thing we're going to add is we're going to add a new statement here that says, okay, count plus 1. Add 1 to count, in other words. Okay, there we go. So if count is less than 15, that's true. We come over here. If we decide if it's a heads or a tails. In fact, either way, we want to add count plus 1. So let me rearrange this. This makes it look wrong. Hold on just a second. Okay. So I'm going to do count plus 1 either way. in either case, I'm going to add 1 to count. Okay. And then we're going to exit the if-else statement, right? And return to here. Count will still be less than 15. So we dive back into the if-else block. Okay, we would either go this way or this way, and we go back. Okay, so this is, see how this is looping back on itself? The program is looping back on itself. That's why this is called a looping structure or a repetition structure, because it repeats the same block of code over and over again. Now, that's fine as long as it eventually ends. Yes, after we do this, while count is 0, 1, 2, 3, 4, all the way up to 14. When it's 14, we execute this one more time, and then count becomes 15, and we go check this statement. 15 is not less than 15. So finally, we have the false direction. Okay, so this is false. And then that means we leave the while loop, okay, and we come back up here. Arrows are messed up. Okay, and then we print things out, and the program's over. Okay, so this is the structure. It looks like 2 ways in and 2 ways out, but in fact it's just the 1 way in and then the possibility to loop for a little while, and then you always eventually leave because this statement always eventually becomes false, and then the rest of the program runs. And that is precisely what happens when we have our while statement back in here and our count stuff back in here. Okay, and it's critical that I don't do this, okay? Because in this case, this will only have 1 added to the counter if we flip tails. So this will run and compile, but it will run until we get 15 tails. That's not what we want. We want it to run 15 times total. And so we put it out here so that this statement gets executed no matter what. Okay, no matter what coin is. All right. Okay, so let's run it. Okay, and we get tails, tails, heads, tails, heads, tails, tails, heads, 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 tails, heads, tails, heads. Let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 times. How many heads were there? 1, 2, 3, 4, 5, 6, 7, 8. And we reported that there were 8 heads, and then we're done. And that's goodbye. Now, to prove that that was truly random, we'll run it again and see that in this case, we only had 4 heads. Okay? And we'll run it again. I don't know how many heads we'll have this time. 7 heads this time. Okay? So that's all the things, that's the 3 main things that we have learned about all in one place. Okay, today. This is conditional statements. Okay, it's conditional statements over here. That would be the if-else, right? And we also saw that we can have multiple conditional statements in the same if, elif, else. We just don't need it this time. Then we've got random numbers. Okay, and so this is a random number between 0 and 1. And then we have a while loop to make parts of the code iterate, okay? And the while loop iterates until this becomes false. What happens if this never becomes false? It's worth taking a look at. If we never update the value of count, what happens? Okay, so let's run this with the count equals count plus 1 commented out. Okay, well, that's bad. Okay, it's still running over here. And in fact, it's never going to stop running until the operating system, the amount of memory given to the program runs up. This is called an infinite loop because every time we dive back in and check this condition, we find that that condition is still true because count is always 0 because we're never updating count. All right, so we're going to go over here. We're going to hit Control Z, or in my case, Control C. If you're in Windows, it's probably Control Z to end this program. Also, you could just close the program and then open things back up. So we need to fix this. Obviously, we're going to move this out. Okay. Like I said, what happens if we do this? Okay, it looks good. It looks good. Unfortunately, we had 20 heads, which is impossible in 15 flips. And I bet if you count, you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tails. Right? Why would that be? Because we were only adding 1 to count every time we had a tails. And so the program ran until we had 15 tails, not 15 total flips, which is what we get if we do that statement every time the while loop runs. Okay. Quick question. What if we want to print out? What if we want to do this 1,000 times? Well, we only need to change this value. Okay. So run it. Okay. It's going to take a while. Oh, but we had exactly 500 heads. That's what we'd expect to have, mostly half heads and half tails. Okay, but we wouldn't get exactly 500 heads every time because these are actual random flips. Okay, I hope I hope you understand. I hope that's useful to you. I have done this out of order, like I said a couple of times before. Because we're learning the syntax and because we're learning about flowcharting at the same time. When you tackle a problem, you should make the flowchart first, right? Make your solution to the problem make sense to you before you start coding the problem. Don't use coding the problem to be the way you figure out how to solve the problem. You should have, if you're going to write the algorithm, you need to know what the algorithm is first, okay? And making the flowchart lets you know what the algorithm is, and then you can convert that flowchart into code, and that'll make your life way easier. Okay, so you'll be using all of the stuff we talked about in the 2 labs this week. You have, as is mentioned in the labs, you have extended time into next week. The caveat being that we'll still be covering a new module next week, module 8. But you have extra time to work on those labs because I think there is a learning curve to figuring them out. They're not difficult, but if you've never programmed before, having all the concepts in the right order in your head can be a little bit challenging. So with that said, please start early, work hard, work daily, and for many hours every day, and you'll get it done in enough time. Also ask questions, and I'm here to answer those questions. Okay, again, I hope you're well, and good luck, and you'll be hearing from me soon.